Good afternoon, and welcome to another Dutch Angular meetup. Today we have a special guest, of course, with a talk about NgRx and WebSockets, but more about that later, because we have two panelists in as well. So how are you doing, Stepan?
Good, very good, thank you.
Yeah, looking forward to what's the subject?
Sure.
Yeah, sure. How are you doing, Jeff?
Yeah, good, thank you. Just off
Yeah.
work, so happy to be here.
I mean, always nice to come out of work and instantly roll into an interesting educational session with the Dutch Angular group, isn't it?
Yeah, right. Always
exactly. Fun. And the man of the hour, of course, Jay. How are you doing?
I'm doing good, thanks. How are you?
Yeah, I'm fine. So tonight we have Jay Bell, CTO and co-founder of Trellis.org, talking to us about NgRx and WebSockets. Jay, take it away.
Awesome, thanks. I'll just go over to my slides. Sweet. So today we're going to talk about NgRx Data, WebSockets, and Nest, and using them to build real-time apps. So who am I? I'm the co-founder and CTO of Trellis.org. We're a social enterprise and an all-in-one fundraising platform for charities and nonprofits. I'm an open source contributor, so I contribute a lot to NX, NgRx when I can, and then a small amount to Nest as well. Author, I'm working on another book, and I've worked on one on Nest.js. And as you can see, I have varying lengths of beards. So I'm a beard aficionado, you might say. So what is NgRx? Well, this is taken directly from the NgRx website. It's a collection of libraries for building reactive applications in Angular. NgRx Store is NgRx's state management solution. Today, we're going to be talking about NgRx Data, and by extension, Store and Effects. So how does NgRx actually work under the hood? Well, you have your store. Your store is essentially your in-memory database. Just store whatever objects, properties, et cetera, your selectors select data from the store, which your components then use. Your reducers reduce to the store, so it updates the store. And actions are things that trigger reducers and effects. Effects are what are called side effects. So you can listen on an action and then dispatch an API call or do some other kind of logic that is more complex. So you don't do that kind of complexity logic with other injected services and DI in your reducers. So this is how the basic NgRx Store and NgRx Effects libraries work. NgRx Data abstracts a lot of this. So with NgRx Data, we have this kind of a flow. NgRx, the website didn't have a nice diagram like the other one, so I kind of just did one up. We have our component, we have our entity data service, which is kind of like a facade. And then we have our entity metadata that defines the entity that we're actually talking about. So like, product or story or, cart, whatever, it can be anything. Normally you do use entities that you do more CRUD related operations on. NgRx Data is not the perfect solution for things like authentication or other complex customized stores like that. So your entity data service is built from the entity metadata, and then your entity data service is what actually communicates with the API. So the entity data service gives you simple things like, .add, .update, .delete, and all of this is handled for you in the background. All you need to do is to define your service. So with NgRx Store and Effects, this is the kind of code that we would end up seeing. I just wrote this up quick. I don't know if it actually works or not, but this is the general structure of it. What we're looking at here is the definition of our store, the definition of our entity. So in this case, it's a story. And then the state itself, and then some actions for getting a story, and then the reducers for getting a story. So what we're looking at here is just the actions and reducers for get by ID. That's it. We don't have add, delete, get all, get by ID, get with query, none of that stuff. And we don't have any of the effects, right? So as you can see, when you're managing tens or hundreds of different entities, the amount of boilerplate just grows exponentially. So with NgRx Data, we can reduce this all down to just this. So what we have is, again, just our story. You can add whatever properties you want. That's any entity in your code base. We have our entity metadata. The only property on that that's absolutely required is the entity name, but you can also add like a sort comparator, a filter function, a custom plural name in case it's not just add an S on the end of it, and then other things like that. But this is all that's needed by default. And then we have our story data service, which is our entity data service from that chart from before. That's it. You now have all of the effects, all of the actions, all of the reducers, the entire store, everything's built out for you for every single CRUD related method that you would need. Done. So yeah, as you can see, that reduces the boilerplate by 10, 20, 30 times. So how does this work? With NgRx data, with NgRx, normally what you do is you would dispatch an action, and then that action would trigger an effect or a reducer, but you can't actually respond to that action because the dispatch method returns void. With NgRx data, one thing that I really like is that all of the methods return observable, and the observable emits and then completes with the value of the successful API call. So when you call .add and then subscribe, what's fired in the subscribe is the added entity that you got back from the API. So how does this work? Well, it actually uses the store and the dispatch in the background. This is just a snippet of code that I pulled out and kind of distilled down from the NgRx code base. Sorry, I know it's a little hard to read because it's all just black text, but so what NgRx data does is and all the methods work somewhat the same. This is just the add one. We generate a correlation ID, which is going to be unique for every action that's dispatched in that instance of the platform, or that instance of the client. We create our action. The data is just in this case, the entity being added. We dispatch the action. And then because we can't respond to that dispatch, we return the store and pipe off of all of the actions. And then we match all of the correlation IDs to find the action that was the success or failure action that had the same correlation ID as the original dispatch action, and then return that data. So that's how we can do this request response type thing using NgRx. So let's take a look at this quickly using the browser and the NgRx dev tools. So if you've never seen the NgRx dev tools, they are awesome. Cool. And if you use NgRx, you should use them. So pull up the Redux dev tools. So what the Redux dev tools do is they give us this entire history of all of the actions that were dispatched, what was in the action, the state at action time, and then the diff. So essentially what happened with the reducer, right? So what we're looking at here is just like a simple, Kanban type board that I built using NgRx data. You can add stories to columns, update the story name, et cetera, right? So if we add a new one, what we're doing right now is we're just using the default REST implementation. We're not using WebSockets quite yet. We'll convert this to WebSockets after. So you can see we added it on the left and it didn't add it on the right. That's because the right doesn't know anything about what the left did, even though they're accessing the same Kanban board. So here we can see that NgRx data dispatched the save add one, and this had the entity ID of CRID2 in it, right? With the data, which is just the story being added. Then it would have dispatched that, triggered an effect. That effect would have made an API call to a Nest server. The Nest server would have returned the data, and then the internal NgRx data effect would have dispatched the success action with that data in it, which is this one. You can see that we now have the full, some of these values were computed on the server, and then the same correlation ID, the CRID2. So that is how that code's able to say, okay, I know this is the success or failure action for my original dispatched action. So I can stop that observable stream, return the data so that if the original calling component or service subscribed, it gets the data back. So that's how NgRx data works at a basic level.
So can I ask a question in between?
Yeah,
Do you
sure.
prefer, so that correlation idea, is that something that's generated by NgRx?
Mm-hmm.
And is that something that needs to be respected by the backend service as well, or not?
Yeah, so when here, I can just go back to this slide here. So this code's taken directly out of the NgRx data code base. So this first line here, correlation ID equals generate correlation ID, that's an actual function that NgRx data will use to track correlation IDs and just essentially keep an internal increment of them. And then when the server goes to return the response, excuse me, that response needs to have the same correlation ID. Otherwise, this pipe will never complete.
Right. So that means that the backend also needs to respect this NgRx data part, like the
Correct.
Yeah. Okay. That's. Thank you. Okay.
Yeah. So, well, I can show you guys some code in a bit after this because we're going to go through the WebSocket one as well. But when you're doing it this way, yeah. So with the WebSocket one, we need to respect the correlation ID, but with the REST implementation, we don't, because the instance of the effect that was triggered from this action dispatch knows what that correlation ID is, right? Because it would have gotten the full action. So then that is what says, okay, well, I got my response back from the API, which is essentially just type T, right? And then I will construct this new action with the same correlation ID and return that. I reuse this concept for the WebSocket implementation, but for the WebSocket implementation, the server does need to know the correlation ID and needs to respect it because WebSockets don't have this request response architecture. So you can't just say, do this and wait for the response, right? So adding in real-time functionality. How do we do this? Well, it's really easy now that there's these libraries. So I created 3 libraries, one for client, which is the Angular and the NgRx side, a core library, which has the TypeScript types. The reason core split out is so that you can use the Angular library, but not have to use Nest, so that you can still respect the TypeScript types and make sure that you're receiving and emitting data correctly. And then a server library for the Nest implementations of everything. So it's essentially just gateway interfaces that you can implement so you know what the functions are accepting and stuff. So how easy is the Angular code change? Well, on the left, we have our plain NgRx data. That's what we just saw. On the right, we have the WebSocket implementation. Instead of extending the entity collection service base, we extend the socket collection service base and then add another injection. That's it. Now our Angular side is using WebSockets as the transport mechanism instead of REST as the transport mechanism. So how does this work? Well, like I said, we reuse a lot of the functionality that, or the same concepts anyway, that NgRx Data uses. So we still have this component data service effect, but now what happens is when we go to dispatch the originating WebSocket event, we dispatch that WebSocket event with a new correlation ID. The API receives that event and then will emit back to that socket, as well as any other sockets connected to that room, however you set that room up. The new event with the correlation ID, which is essentially the success or failure event, right? And then NgRx Data will then, pipe off of the stream of WebSockets of events being returned, find one with the correlation ID, and then reduce that data back into the store. So we essentially duplicate that concept. It's just there's one being done between the entity data service and the effect, and there's one being done between the effect and the API with the correlation IDs. In this case, the API needs to emit the sockets in a certain way, which is what the TypeScript types help with, because you need to have that correlation ID in there. Otherwise, the stream never completes and we never reduce the data into the store. Okay, so let's take a look at how this works with WebSockets. So we have this WebSocket implementation. And then, so theoretically, if we make a change on one screen, it's also going to make the change on the other screen, right? So let's see, we add a new story, boom, happened on both. So what exactly is happening here, right? We have our original, we're looking at the left screen in the Redux DevTools, we have our original NgRx data save add one. So this hasn't changed. This is still the same action being dispatched by NgRx, which just says, add a new one, right? With our action and the correlation ID, right? Then what happens is the library takes over and says, okay, instead of using REST, I'm going to use WebSockets, and I need to create a new correlation ID specifically for this WebSocket request response, right? So we have a new correlation ID here, and then our data, right? So that will be then emitted, and then we will be returning a stream of all the WebSocket events being pushed to the client. Server will emit the success, which is this one. You can see that we have the same correlation ID, CRID4, here on the success. That will then pipe back into the NgRx data store, which then this library parses these actions into the corresponding action that NgRx Data is expecting, which will then emit save add one success, which is the same correlation ID as the first action, the save add one, and then that will then trigger the reducer. So that's the action structure of the request response using WebSockets. Now, how did the data get onto the right screen, right? Because that one wasn't the one that dispatched the action or anything. Well, the right screen and the left screen are both connected to the same socket room, right? The left one just happens to be dispatching actions. The right one's still getting all of the success response or success actions, right? So what happens is the only action this one receives is a save add one success. But because it doesn't have the correlation ID, it doesn't know anything with the correlation ID, it wasn't the one that generated the correlation ID, right? It just gets the data and says, okay, well, someone else successfully added one. So I will also successfully add that one into my store. So then we parse this action into what NgRx Data is expecting. And then that will then, NgRx will take over, we'll reduce that data into the store, and it shows up on the client. So how does this actually work in the backend? Well, let's take a look. So we have a gateway. So a gateway is just, what listens to and dispatches WebSockets in Nest. I don't actually know if they're called the same thing in other web services, to be honest, but in Nest, they're gateways. So this right here, socket entity gateway base, that's one of the types provided by the server library so that you can implement this and know what the different functions are, what they're supposed to return, what the socket body, like the message body is, and all that kind of stuff. So we'll look at, let's do save update one. Excuse me. So what happens here is we subscribe to a message, which is a socket op. This is another type defined by core because both the client and the server need to respect the same, socket IO event names. Update one. Our body is going to be socket event body. This is a generic of, update request payload of story. So now we know exactly what structure our body is in. So, just some code, we'll find one and then update it, whatever. This is just Mongo, but whatever your data access layer is, it is irrelevant to this implementation. So now what we'll do is now that we have the updated story, we'll emit that updated story, which is a socket op of save update one success, right? This is what all the other clients other than the dispatching client are going to receive. Our data, the ID changes, and then change. That's just a flag in NgRx Data. Excuse me. And then we're going to return the action. Well, we'll return the data with the correlation ID, which is inside the body here. This is the one that the originating client is going to get, which is going to match the correlation ID, reduce the data back into the store, and complete that observable stream, right? So that is, and we set this return value up here of promise socket event return of save update one success response payload. So again, there's just these typings here, so you know that this will be type safe, so that your client is receiving the correct data. Questions. So I have the GitHub repo here. I'll supply this to the organizers so that if anybody else wants it, they can grab it. My Twitter, if you ever have any questions about it, and then a link to where these three packages are hosted. To note on this, currently it's using Socket IO v2 because that's what Nest supports. I believe the new version of Nest is going to be using version 3 or version 4, which was Socket IO's v3 or v4 is rewritten in TypeScript. So the types are much, much better. V2 is kind of painful to work with in TypeScript. So the typings are kind of like any for some of it right now, which is obviously not good practice, but it works. We're not using this in production yet anyway. I don't know if anybody using it in production. So it's kind of just like a see if this is possible type thing. And then I have a branch that I've been using to update to Socket IO v4. So all the types are updated and nice. Yeah.
Awesome.
And that's it. Should I clarify anything? Does anyone have any questions about that?
Well, there was some question in chat already from Fabrizio Bastian. Does this require full control over the backend API, or is there any other way of doing this? I can guess the answer here, right? Yeah.
Yes, you would need to be able to build the backend API for sure. Your normal, I mean, like, of course, everybody's implementations of their APIs are different, right? So you can't expect an API you don't have control over to be returning the correlation ID, nor returning the data in the way that NgRx Data is expecting it to be returned.
I guess if we want to flip that question on its head, though, because the WebSocket specific part really requires it, but I think you also mentioned that the REST API part doesn't.
No,
like you could use NgRx Data in the way you just described, except it won't have that synchronization between clients. I guess that's the thing you're missing.
Yes, exactly. As long as your the API you're communicating with follows, the consistent REST patterns, then you're good to go.
Yeah. So if you want to use WebSockets, Fabricio, you'll probably need some control over that endpoint. Yeah.
Now there is the opportunity for an extension point in this library to add like a transformer, so that if you know what your server is going to be responding with, you might be able to transform the data into what this library is expecting. But I've never looked into that before. But you never know.
I guess there's some cool polling things you could try. Like if you have a REST endpoint that gives you changes, you could write a poller that just asks that and simulates synchronicity, but it's not the same as using WebSockets.
No, it's really not.
Yeah. All right. Very cool.
Just a question. So when would you use like NgRx Data with WebSocket? Because it's like really CRUD based, and for me it's like, okay, if you need to, the only way I can see it is when you need real-time stuff, but would it then like just a servers be enough? Let's call it like that, like just simple Angular service that's connected to the WebSocket and just transforms the data in specific ways. Yeah.
So what you get with NgRx Data that you don't get with the just a plain Angular service, right, is the additional logic around abstracting the reducers, the actions. Even the HTTP client is all abstracted out into the background of NgRx Data. So you could do it your way for sure, and then your service would just need to subscribe to the results of the event and then reduce them into the store kind of thing. I'm gonna be completely honest, I don't know what the perfect solution or perfect use case for this library. I built this as like I wonder if it's possible. And then we've kind of started to talk about it internally in my company, because we have like what we call our fundraiser builder in the platform. So we have tons of different entities. And at some point we want to implement the ability for multiple people to be editing their fundraiser at the same time, right? Adding tickets, adding donations, updating auction items, et cetera, right? And then this just abstracts out a lot of that, manage the data in the store, creating all of our actions, managing the services and all that kind of stuff all into the background. And we just have the one service that we call. So it kind of just reduces the boilerplate while also giving you that real-time NgRx state functionality, right? Because your state's just always going to be updated, which means your UI is always going to be updated. If you went the service route and just listened onto sockets, you would need to manage your dispatch, your like actions and your reducers and all that kind of stuff yourself.
Yeah. Okay. Yeah.
So don't know what the perfect use case is, to be honest.
Yeah, and under the hood, it's like also like NgRx entity, right? That people just adopt. So NgRx Data just adopted entity under the hood.
Yes, yeah. NgRx Data just uses entity because it was originally written outside of the NgRx repo, like it wasn't part of the project, and then they moved it in.
Okay, great. So maybe some people are looking right now, and when would you go the WebSocket way versus the REST way? And of course, well, the Kanban is like the perfect solution, but would you go like with a ticket system? Because we chatted a little bit earlier, for example, in a financial situation, I don't see why you need to have it like instant there. Would it be just basically when you do like real-time data tickets, that kind of stuff, would use something like this?
Yeah. So that's what I would suggest. Don't shoehorn WebSockets into a use case that doesn't need to be real time, right? If you're building an application that has multiple users viewing the same data around data that is structured in like the entity type way, then this might be a good solution for you. But don't try and shoehorn WebSockets into a non-real time use case because you're just overcomplicating it, right? And then B, don't try and use this for like unstructured data. This is specifically meant for CRUD type operations on entities. So, tickets, a Kanban board, something where people are viewing the same data in a structured way. This would be good for because then the changes are happening regardless of who's.
I guess the use case, most important part of that use case also is that the real-time part, of course, is important. Like if it's important to always have the most actual reality, view on reality, I guess. Like with a ticketing system, this would be perfect. Like if you're a customer support call center type of application, then it would be very useful to see, oh, somebody's already answered this, now currently opening this this ticket or whatever. So
yeah, 100%.
Multiplayer board games by Marco van Belen. Yeah, absolutely. Multiplayer games. That's absolutely why you want to be using something like this.
Yeah. Multiplayer games is an interesting one because multiplayer games can be both a perfect use case and a not good use case.
Absolutely.
Right?
Yep.
If the game, again, isn't structured data, isn't CRUD type thing, it's more just like user actions, probably not the right solution for you. You should just use, if you want to use NgRx, then use NgRx, but you should probably just write your own wrapper around WebSockets and build your custom functionality for all the different user actions, whatever those might be, right? But if it's like a, like what you said, like a board game, right?
Yeah, he said multiplayer board games.
Everybody's played multiplayer board games together. This would be great.
Yeah.
Well, yeah, it could work, is what I'll say.
There's plenty of use cases thinkable, but I think what you said makes a very good point. Like, don't try to put anything that could be real time on the WebSockets, only if it needs it, and the data structure has to be clear in that sense. It has to be predictable. Yes. Yeah.
Exactly. Yeah, because it is all of your CRUD, get all that kind of like get by ID, get by query, all that kind of stuff is based off of the interface you provided in your entity metadata, right? So it's not super easy to store, additional properties, transform that at, reducer time. There are ways to provide custom reducers and there are ways to provide additional properties and stuff like that. But this is just a general rule of thumb. Don't shoehorn things into use cases that they don't fit.
I mean, of course you can if it's for fun, but not in a real life situation. Yeah. Yes. I mean, like you started this, like, can I make this work with WebSockets? Yes, I can. Yeah.
Yeah,
so
exactly. Exactly. So.
Merciless asking if there's a code repo and or documentation. I think at least the repo I'm 100% sure of. The documentation probably within the packages you showed, right?
Yeah. So I think that NPM has the README up there as well. I'll provide all the links to the organizers so they can send them out. Yeah,
I think the way we're going to share them again is check out the Twitter. J. Cooper Bell, I think. Yep. Did I say that correctly? Yeah. And I guess the Dutch Angular group will also be posting that same link as a service to the viewers. So make sure you check out the Twitter. If I had the link right now, I'd slap it into the chat, but I don't have it right now. But that'll come later. So we'll make sure that it'll be in the description here as well.
Mm-hmm.
Yeah, we'll figure it out.
We'll figure it out. Yeah, we'll be right.
But so I still have another question, and I was just wondering because, and I'm a bit. Our last presentation was also around WebSockets, so I'm pretty curious how you did like authorization with the WebSockets part. Did you experiment with it or?
Yeah, so the way that the library wraps, because with NgRx Data, with just the REST implementation, right? Obviously, it's just you just use an HTTP interceptor kind of thing, right? Classic Angular, right? With the WebSocket implementation, the entity data service that you create, so in this case, the story data service, actually exposes an additional method beyond just the CRUD ones called connect. And connect just takes in the same properties that the socket.io connect method would take in. So you do authorization the exact same way as you would with a normal socket.io implementation. I don't assume anything about that. That is one of the places where it's kind of like any for the time being until Socket.io v3 or v4 is in there, because the v2 types kind of suck. But or at least I wasn't able to figure them out. But I don't assume anything about your implementation. There's just a method that you can call to connect to the WebSocket whenever you want to do it.
Okay, great. And I'm not sure about this. How WebSocket is, because I've never experimented with it. Does it like do auto reconnect, or is it something that your package is doing? Or
yeah, so depending on what implementation of sockets you're using, like the native WebSocket implementation in browsers, I don't believe automatically reconnects. Someone correct me if I'm wrong, but I don't think it does. Where Socket.io has, Socket.io reconnects, has reconnection built into the package.
Okay. Yeah. So if you're implementing in a different way than Socket.io, you probably need some logic to look at it, reconnect with it, and that kind of stuff.
I think there are default out of the box if you're using Socket.io on the backend, but not 100% sure because it's been a couple of years since I've used it. But I think it does have automatic events for on connect and on disconnect automatically.
It does.
Yeah. So you could just listen to these and have your retry logic in there. So, but it's definitely something to check out the Socket.io API for that.
Yeah, and I've thought about, like, if people start using this and want this feature, I've thought about implementing a way for you to provide your own, socket implementation rather than being forced to use Socket.io kind of thing, right? So you can provide just, a class that extends an interface with normalized methods kind of thing, because then someone could use the native socket or WebSocket implementation if that's what they really wanted to do. But obviously, again, this was just for fun, but so I didn't do that. I also know Socket.io. I don't know any other socket implementations because we use Socket.io at Trellis.
I think there's the directly on the node, like the direct native one.
Mm-hmm.
Socket.io is just a wrapper around that one and giving you some helper utilities, I'd say, like the on-connecting and disconnecting.
Yeah.
That's. Yeah. I mean, I think Socket.io on itself is pretty light, and just on the client side, it's very like a little bit more packed because it has all these fallbacks and all that. So.
Totally.
All right.
Yeah.
Very cool. Are you still more questions, Jeff?
Yeah, I'm thinking about it because I'm still thinking about it because I can probably ask a lot of questions around this, and I'm pretty curious. But you don't have the numbers, like what the performance is this way, and how would that scale like that. But it's just because I don't have any experience with WebSockets and that kind of stuff.
Actually, kind of an interesting question, because the whole scaling of a WebSocket, like especially if I'm thinking about like having thousands of people in a chat or whatever, or like in a game or whatever, like being able to replicate and cluster Node.js WebSockets would be very difficult and interesting, I'd say.
Yeah. So I'll give you guys a real in production use case. So we use sockets at Trellis, right? And we have a lot of real-time features to our platform. So like we actually have like a live and a silent auction function, like feature built into Trellis. So like think eBay, but for charities, and that is all real time. So we're currently using Socket.io with NgRx to do real time bidding kind of thing, right? So we haven't gotten to the point of thousands of people quite yet. We've only had like I think hundreds kind of thing. But as long as you're building it correctly, right? And you're leveraging the NgRx store, right? So, like building out your store so you can, leverage memoization. So you're not like always breaking memoization and always running change detection on all of your components, right? Because I mean, that's just a rule. You're just going to screw yourself regardless of what technology you're using if you don't use memoization correctly, right? If you get to scale. And then the other optimization point that you could do is you could start batching events, right? So rather than, request response, it could be request and then like batches of responses together kind of thing. So that now instead of, thinking back to the code where we dispatch and then pipe off and return and filter by correlation ID, you would just need to like flatten all of the actions that come through. So you're like finding a correlation ID in a list of responses kind of thing to see if you got the response back. So like that would be one way, because then you can reduce all of those events into the store at the same time. So it's just one memoization break rather than like one break for every single change, so you don't always have change detection running. And then, of course, you would want to build your components in a way so that you're not, initiating change detection at your root element. You're initiating change detection only where that data is actually stored. So using, feature UI type structure inside the code, and then, leveraging things like the NgRx push pipe, which coalesces change detection so that you don't the async pipe's awesome, but it doesn't coalesce change detection. So you kind of just get this over, you do too much change detection, really.
Yeah.
So the NgRx push pipe will just coalesce it together and kind of just optimize it that way.
Okay.
Just thinking about this hypothetically, if you're doing batched and all that, wouldn't it be, and this is just a general, just randomly thinking out loud right now, wouldn't it be better to get rid of that whole correlation ID? Because the reason you have it and use it is that you can locally already save and update your state whilst waiting for a response from the server. And as soon as the server says, nah, none of that, then you know which item to remove again. Mm-hmm. You could make it a little bit more passive, and WebSockets are quite fast, usually, depending on the ping, I guess. But if you remove all that logic and make it way easier, then you have just the single dispatch to server. Server says, sure, we got it. And then next on that will be a batch coming in, including your newly created item.
Yeah, so that's definitely possible. But then you lose out on one of the features of NgRx Data itself, where you can subscribe to the action that you dispatched. So when you call, story data service.add, you can subscribe to that. If you removed that correlation ID, then it would be, I'm not gonna say it's impossible, but it would be much harder to be able to receive the data back from the data service.
Yeah, so but that's the same thing. Instead of what I'm probably saying here is that instead of making sure you have a direct response that you can listen to and you can probably hook another event or effects in or whatever. If you give that up and make it more fire and forget, so I create new ticket, boom, ticket's gone, and then in that next batch, my new ticket will be in there.
Oh yeah, totally. Yeah, you could 100% do that for sure. The library could even be altered to support one or the other, right? Maybe even on the call, you could say make the call, but I don't care.
Yeah, I'm not. Right. Oh yeah, exactly. Give it a flag or something. Do you want to listen to this or not? And if it's no, then no the correlation and fire.
It just
and if it's yes, then correlation and here we go. Yeah. Well, I mean, that's pretty cool that you could do that. Yeah, that's interesting. Opt-in.
Yeah.
Opt-in listening.
I mean, anything's possible with programming,
of course. So, the question is, do you want to, and why would you want to? Yeah.
And how to do it.
Yeah, fair enough.
Yeah. So.
Cool.
So did you do this implementation also without NgRx Data or a similar way, let's call it, just with the store, for example?
Yeah, so like I said, we're not using this library in production right now at Trellis, but we are using a different library I built that currently not open source, but I've been rebuilding it slowly to make it good enough to open source. Right now it's a little hacky, but we have an implementation where you can essentially, it's the NgRx WebSocket connector that we have in our code, and you can pass it a configuration object of the namespace, the URL, the array of events to listen to, and what action each of those events dispatch to, so that you can, on a NgRx feature basis, configure what events are dispatched, what events are emitted or received, and then what actions are dispatched and how they're reduced into the store. So that's how we do all of our WebSocket NgRx stuff in the code base currently. So you just, set it and forget it pretty much, right? Because then there's just this stream of WebSocket events coming into the store that just reduce into the store.
Did you also start with the HTTP REST and then just go to the WebSocket part, or did you start with the WebSockets already? Because probably that you're doing bidding and that kind of stuff.
We went right to WebSockets for the parts we needed. It has to be real time.
I can imagine that.
Because we have our silent auctions and our live auctions, but we also have a live streaming feature, so that the organizer can control the screen of everybody viewing it. So that's all WebSockets as well, obviously, right? We have real-time leaderboards and real-time donation goals and tickers and all these kinds of things. So all of those are using the WebSocket connector to connect the events to reduce.
Great to join, Sander.
Yeah, hi. Sorry for being late. Hi, how are you doing?
Good, how are you?
I'm doing fine. I'm having a couple of days off, and I was out a little bit longer than planned.
Well, we're still live, so we're still we're basically
time.
interviewing Jay right now. So
Yeah, it seems like it.
yeah, and we're having a great time just talking about NgRx in coalitions, mainly with WebSockets, but it touches upon different subjects here and there.
Well, I think, Sander, you've seen me talk about this before at Utah, maybe? I can't remember what one it was now.
I think Liverpool.
Or Birmingham.
Birmingham.
Birmingham, yeah. That's what it was. Yeah.
Yeah, I think the idea of combining WebSocket with NgRx is really interesting if you have a use case like yours. It's like a proper fit for that.
Funny that you mentioned use cases, because about 10 minutes of the discussion was about use cases. So
yeah, it's definitely not something you want to use for everything. Like I said before, please do not use WebSockets unless you need WebSockets. Don't overcomplicate your software for the coolness of a feature.
Yeah,
right?
Unless you're researching, I guess.
yeah, exactly. Yeah. But I mean, that goes with literally every technology out there, right? Like, just don't use something you don't need. If you're trying to do a production level application that you're right?
We experts need a living, so stop.
Got to keep on pushing that boundary. The cutting edge always has to be pushed forward.
Yeah, no, machine learning and everything. Add some AI into your Kanban board. All of those things.
Exactly. Yeah, that's otherwise it will break in a couple of months.
Totally.
All the cool stuff needs to be there.
Yeah, and we'll be out of jobs, right?
Exactly. Yeah.
Right. That's what Sander's saying. I think is that we just won't have a job if we're not overcomplicating everything. Or am I putting words in your mouth, Sander?
No. I'm having a good job undoing all the overcomplications of others.
So we need these people as well.
Yes. Yeah. I do love to build
both sides of the coin.
Yeah.
Yeah, the reason that most of us have a job is because a lot of things are way overcomplicated from the get-go, where they shouldn't.
It's true.
But that's just how it goes.
That's the world we live in, right?
That's the world we live in.
Well,
Especially the front end.
Yes. Yeah.
Especially in front end. Also, there is a reason for this, because a lot of people don't understand the area they are working in, so they start off with basically coding for everything that could happen, and only when they properly understand the whole thing they think, oh, this thing is a mess, but I've spent 10,000 hours on this, I'm not going to redo it.
Yeah, that's fair.
Cost fallacy.
Yeah, exactly. Oh, I've already spent $1 million on this. Like, I'm not going to just give up on it now.
Yeah.
Well,
that would be silly. Yeah.
Yeah, that would be dumb.
I guess in regards to the show, if there are no more questions from chat, thank you so much. Give that man a good follow. Jay Cooper Bell on Twitter. He'll be posting some repo and documentation, and we'll be happy to reshare that for you. Thanks for joining us tonight. Jay, you especially, of course, with that excellent presentation. Thanks for the good discussion afterwards. And we'll see you next week with Mark Whitfield, if I'm not mistaken.
Correct.
Awesome.
Have a good
off
one.
to work.
Yeah. Have a good one, people. See you next week.
Yep.
Bye-bye.
Yeah.
Bye.